Sound design.
If the FCC prosecuted sound system designers for poor array design, they'd be putting us in jail if you looked at how we spew energy into rooms.
Sound design. Sound Design Live is produced independently by me, Nathan Lively, in Minneapolis, Minnesota. All right, so Pat, what are we doing in North Carolina?
We are conducting one of our training classes. This is sound system design, which is mostly about loudspeaker selection, placement, room acoustics, and laying out sound systems. So we're down here for a week doing that.
All right, cool. And the people who come to this class, a lot of them are sound system designers for like install companies, but I also noticed that there are people here that just run sound at churches. I'm here and I do live sound, so it sounds like there's people from all over, but it especially appeals to those people who are dealing with design and the output stage over and over again.
Yeah, sort of the way we explain it is that if you're involved in the selection and placement of loudspeakers for sound reinforcement applications, then there's something in this class for you. And of course, that's a very broad group of people. We get a lot of military people. We get staff from colleges.
People doing audio in the military.
Yeah, for sure. Yeah, they have a lot of auditoriums in the military. Yeah, we've done classes down here at Fort Bragg in North Carolina because they've got an audio staff down there. So, there's a lot to loudspeaker selection and placement because, that ends up being a filter that everything goes through. It doesn't matter how good your digital mixer is if it goes through the wrong loudspeaker in the wrong place. So we try to optimize the system by getting the right thing in the right place the first time.
I guess until we have receivers implanted in our heads, we all have to deal with the physics of going through air.
That's always been Don Davis's contention, is that's eventually how we'll do it. But it doesn't appear like that's going to happen during my lifetime. So,
okay, speaking of Don Davis,
yeah.
I was so happy that on the first day you talked about how difficult it was for you the first time you tried to read Sound System Engineering, the yellow book.
It was impossible, yeah.
Because I am about a third of the way into it, and it has been a slog. And so it felt so good for me to hear you say it was hard for you too at the beginning.
It was, and it's not a cover-to-cover read. When people get that book from us, I always say, now, don't sit down and try to read this thing cover to cover. It's kind of like reading the phone book or something. Yeah. It's really more of a reference. When I got the first version of that book back in the 70s, I had never been exposed to any kind of engineering approach to sound. I was just winging it, hanging boxes up there and pointing them. And I got lucky on enough projects where they worked, and I got paid, and I was sort of a contractor in the contracting business. And it wasn't until I picked the wrong loudspeaker for the wrong room, for the room that may be interested in finding out if there are any rules bounding this. And that's what sound system engineering gives you, is the mathematical relationships between things. And I think that's probably what Don Davis gets credited with more than anything, is more of a deterministic approach to coming up with this stuff rather than it just being a pure art form of some type.
If that was my first book on audio, I feel like I would have been overwhelmed with the science of it if I had spent all of my time up until that point only in the art of it. I'm not saying that's what you did, but...
No, it was overwhelming to me, but in a sort of a good sort of way, because I was glad that I found a body of information I didn't know anything about, because I had just screwed up a system really bad.
Okay.
And so if I bought a book...
This is your motivation.
Yeah, that was my motivation. Yeah. So I wanted to know what I did wrong.
Sure.
So I was glad to find out that I did everything wrong on that system. And I wasn't thinking about the directivity of the loudspeaker and the pattern and the uniformness of coverage, the speech intelligibility, how much reverberation my selections were generating in the space. And all of those things are big, big factors and need to be considered up front, not after the fact. We don't have any knobs to adjust that stuff. It's cooked into the loudspeaker selection and placement.
You had said that one of the ways to define being an expert is someone who has done certain things wrong, enough things that they knew how to do things wrong, and so now the opposite of that, they know how to do things right. So for many of us who find ourselves maybe falling into this career as a practitioner, I think that's the way most of us get started, is experience doing things right, learning in the field. I guess it's things like SynodCon and Sound System Engineering book that we hope will kind of speed up that whole process. We don't want to have to reinvent the wheel all over again and make all the same mistakes that everyone else did.
Yeah.
And so I guess that's one of the reasons that I come to things like this is I want to find out what you did wrong so I can save some time.
Sure. And that's what we tell people that we're here for, is we're here to shorten your learning curve. I want you to get in a week what it took me a year to get.
Sure.
You know, that's our product, because the information can be gotten from various places, but we try to package it and streamline it and make it a process so that you can get it quickly, deploy it quickly, and benefit from it quickly. And I believe it does speed up the process, but I always warn people that it's probably going to slow down the process before it speeds up the process, because you're going to be thinking about things that you didn't think about before. And the secret or the key is to do it enough times and often enough to where you don't have to think about the steps each time. It becomes more second nature to you. But anytime you do anything the first time, you have to remember this step, you have to remember this step, and it slows you down. Yeah. But I always tell people that, you know, when I was, you know, learning these things and trying to implement what was in the book, I made myself do it, even though I knew from intuition I could throw something up there and make it work and get on to the next thing. Yeah. But I still made myself go through the process because I wanted to develop the intuition for the process.
Yeah.
And eventually then, I mean, your system designs are a lot faster because you don't have to think about the process. It just happens. You just do it.
Yeah.
But you have to do it a lot to get to that point. Yeah.
Pat, I want to talk more about the teaching that you do in SynodCon, but before we do that, what's the very first record that you bought with your own money?
Oh my, that was in the way back category there. I'm pretty sure it was Abbey Road by the Beatles. Yeah, listened to through a terrible Magnavox console, you know, turntable, loudspeakers, amplifier, tube system.
How did you get your very first job in audio, like the first one that paid you money?
I worked my way through college giving guitar lessons. So there was a local guitar shop, and I would give up to like 60 lessons a week, and they're 30-minute lessons, so that's like a 30-hour work week, going to school full-time, taking 18 hours. But I was paying my tuition as I went through that, doing that, so you know I didn't incur any debt along the way. But after making it through school and you know, ready to go out and get a job in the real world, the guy that owned the music store I worked at said, "Why don't you let me sell you this place?" Because he wanted to move on to something else.
Wow.
So I ended up buying the music store
Really?
that I gave lessons at.
God.
So I went from the University of Louisville engineering school into retail music. And I've always said that everybody should have to do retail for a while. And especially everybody should have to do retail music for a while, because it's a wild, crazy world. You know, we sold guitars, amps, sound equipment. I had an electronics background, so I did factory service for a bunch of amplifier brands and was a guitar technician and did all of that for about 8.5 years. Mm-hmm. And about halfway through that stint owning the music store, you know, I used to have people come in and, I sold a lot of loudspeakers and portable systems, but people would say, "Hey, can you hang these things up?" And I'd say, "Well, I don't know why not." You know, so I started installing loudspeakers and found that if you sold an installed system, not only could you get full retail price for the box itself, but you could actually charge for your labor to install it. Sure. So I was coming from a world of 30% discounts for boxes carried out the door to full retail price plus labor for installed systems. And I said, hey, contracting is something I could grow old with. Huh. You know, so I started, I think my first project was a little local elementary school that needed some stuff put in the gym, and hung a couple of boxes up there. And it's a gym that anything would have worked in. And it sounded fine, and I got paid, and I got to get out of the shop and drive around in a truck and put ladders up and climb. And
How did they find out about you? You were just the music store.
The music store was a great front end for contracting, because people would come in to buy instruments and stuff. And we were associated with sound, and we sold PAs and mixers and stuff. And to this day, the music store makes a great front end for a contracting business, assuming that, the people running the music store become competent in the field. You actually can get a lot of work just from people walking in the door.
Pat, looking back on your career so far, what do you think is one of the best decisions you made to get more of the work that you really love?
I think one of the toughest decisions and hardest things to do at the time was when I bought my first serious analyzer in the 1980s.
Okay.
It was a
I heard about this.
Yeah, TEF 12 analyzer, which was $12,000 in 1988 dollars. And I didn't have the money, so I had to go to the bank and borrow it. And it was as much as a car would cost at the time. And I can remember sitting across from the banker and him looking at me and saying, okay, you got good credit. I can loan you the money for this, but you realize that next year this thing's going to be worth 10 cents on the dollar. Wow. And I thought, he's probably right. But at the same time, I was following Synodcon at the time, they were heavy into the TEF platform for measuring, among other things. And I thought, if I'm going to be in this business long term, I need to get tooled up with.
And this is the only way to get your hands on one. I mean, you can't download an app. You could just go rent one at the local something.
No, this is a 50-pound thing with 5 1/4-inch floppy disks in it and a little monochrome screen and absolutely pure mystery to me out of the box. And one of the things you could do with the TEF.
Wait, you spent all this money and you had no idea how to use it?
I had no idea. All I knew is that you could measure arrival times of stuff.
Okay.
So if you needed to time 2 loudspeakers, the TEF would tell you what delay to dial in. So I bought this thing and I thought I was going to time align the world, So I got it out of the box and went out, and I remember setting it up in a church and putting the mic up and it's like, well, now what? And it's like, well, how do you even operate this thing? There's a keyboard and there's a dot prompt and you have to type commands into it. So I had to pack it all back up and go home and learn how to use it. And it was a long process. It was really challenging.
What I love about this so far is that this is the same process that now everyone else still goes through. It doesn't matter what they buy.
Smart rig, whatever.
It's so much more accessible now, but the first thing everyone does is download the thing and then immediately takes it to work on a show.
Yes.
Like, here we go, let's use it. And like, oh, wait. I should have practiced. And then you go back home.
I get that call all the time. Okay, Pat, I'm out in the room. I've got my mic up. I've got my USB card hooked up. Now what?
Yeah.
And I always say, pack it all back up.
Yep.
Go home, lock yourself in your living room, get a couple of little loudspeakers, and learn how to drive the thing. Yeah, it's not a trivial process. But you'll learn a lot of stuff doing it, for sure.
What do you think is one of the most common mistakes you see people making who are new to sound system design?
Well, it's usually the wrong speaker in the wrong place.
Okay.
And not thinking about how loudspeakers interact with each other. Because when you put 2 loudspeakers next to each other, you create a different loudspeaker. It's a new thing that may not be anything like what it is that you want. And we've always said that if the FCC prosecuted sound system designers for poor array design like you would for a poor antenna design or something in an RF system, they'd be putting us in jail if you looked at how we spew energy into rooms. Sure. It's usually not at all what you want. And then to compound the problem, it's a poor performing system, and then you go in with the equalizer to try to fix it, and you usually just make it worse because you're not using the proper tool to fix it, or it can't be fixed. It may not even be possible with filters to even correct it if the timing is off and things like that. So loudspeaker selection and placement, still the most critical part of the process, for sure.
I'm not sure if it's the same for everyone, but I can tell you for sure, for me, that happened because I started out in recording studios. And so then when I got into live sound, I thought, oh, okay, speakers go way out here and they should point through the center. And like, that's how you set up a sound system. And then I had all kind of problems. And now I get into similar conversations with other people like, well, I put them way out here and pointed them this way. Well, that's like a recording studio. So I can understand how people's experience with just seeing things done in a recording studio or at home, home theater, car stereo, I don't know, whatever their experience is, then that doesn't necessarily work.
It doesn't. And it's not an intuitive process. There are, and I think back in my retail days when I was selling gear out of the music store and trying to explain to people how to install it themselves, how many times I told them how to do it wrong.
Okay.
Exactly what you just described, because intuitively it seemed right.
Sure.
And I wasn't thinking about the stuff that really mattered, the direct to reverberant ratio, the evenness of coverage. And, it's you have to be using the proper set of rules for the types of environments you're working in. And when you get into big live spaces, the rules are different than they are for your living room or for your recording studio. And in those smaller environments, there's not really any wasted energy. I mean, it can bounce around a bunch of times and still actually be useful in the listening process. But when you get into these large spaces, anything that, past that first arrival ends up coming back and haunting you as interference later. So you have to minimize the excitation of the room because you're creating your own interference if you're not thinking about that.
And this most common problem that you just described of speaker choice and placement is not a problem because you don't have the right tools. I mean, it's the wrong speaker, but it's not because you don't have the right design tools. I mean, you start out on day one talking about how the reason we're all here is because there's no automatic system design app. There are lots of prediction softwares that can help us, and we even have things like auto set, aim, and splay, and all of these computers trying to help us, but we as humans and designers still have to say, this is the speaker and this is where it goes.
I always start the class with a graphic up there of this guy stretched over a drawing board, and I always, it's just a cartoon sort of thing, but I say that's a sound system designer. That's a human being. And sound system design is a human process. There's decision making, there's judgment, and fortunately it can't at this point in time be accomplished by artificial intelligence or anything. That may not always be true in the future, but it's true today. And there's an artistic side of this that can be missed if you try to just reduce it to an algorithm or something. I still believe in human exceptionalism. I think that for a lot of things, a human is the best way to accomplish task. And we spend so much of technology trying to replace humans, but I look at a lot of things, it's like, why do you want to replace a human? A human is the best, way to get that done. And so the best we can do today is sort of badly imitate humans in some regard. I mean, they'll have this robot that can walk up the mountain, but a human can do that, and it doesn't require all of that technology.
Progress.
Yeah. So humans are sound system designers, and that's what makes it an interesting business. And hopefully we don't get, an app that does that, because that will probably just enable people to do something that they probably shouldn't be doing, if it can be done with an app.
We don't need to go much deeper into this. I think we talked about it pretty well, but there's a great quote by George Lucas, I think, who said that, new technologies will always be used wrong for a while when they first come out. And, it reminds me of in the 90s, Pro Tools coming out and recording studios freaking out, and then, audio analyzers getting more easy access. And now I feel like we're kind of in the age of people. It's great that we have them, and people also misusing them, and people freak out about that. So any new technology, it seems like, easily gets misused until we sort of get enough understanding and education.
That's absolutely true. And people sometimes fail to consider, there's a lot to a sound system. It's a complex system. And not just setting it up, but also operating it. And a good mix engineer has got a skill set there that's hard to teach to somebody else, because it is a combination of art and science and judgment and politics and all of the things that go along with it. So sound is not a trivial thing. And we wouldn't walk into a piano store and buy a piano and drag it home and expect to play it right away. Well, the same thing is true with sound systems. There's a learning curve, and there's rules. And people often go out and try to use this stuff without knowing the basic stuff. That's one of the reasons I created our most basic online training course, our Course 50, How Sound Systems Work. And my idea behind that was that anybody that touches sound gear, this is the stuff they need to be familiar with. And it's an introduction to the terms and, some of the processes and things. It doesn't make you an expert, but it at least exposes you to the body of information, involved in doing sound, as we would say.
What is one of maybe the most painful mistakes you made, and how did you recover?
My worst install I did in those early years was I took the system that I was putting in, smaller dead rooms, sound system, and I put it in a large Methodist church, a reverberant space used to play pipe organ and choral music in. And it was a beautiful system. The cabinets were wood grain. Aesthetically, it was very pleasing. But when you spoke over that system, you couldn't tell what language was being spoken. It was so bad. And that's where I got my introduction
Wow,
to...
so it got installed and everything, and you didn't find out till...
No, I didn't know until it was done, and we stood out there and listened to it. And at that point, it's like, what do you do? You know, what do you do? And that's when I found Don Davis's original book at the local electronics bookstore. Sure. And because I thought, how could this happen? I've been through, I've had training in electronics. How could I have screwed this up that bad? And so I got his book and read it and found out that I'd made a lot of mistakes. And I wasn't thinking about direct-to-reverberant ratio and loudspeaker selection and placement, and it didn't drive the design. And so to make a long story short, I had to fix that system, on my own nickel. I had to pay for it because I wanted to preserve my reputation, and I wanted to preserve the relationship with the client, and I wanted to learn something.
With the client go? I was curious about that.
Well, it was a little embarrassing. It was a little embarrassing. It was a lot embarrassing. Yeah, so I ended up redoing the system and paid for it, and still to this day have a good relationship with those folks.
Oh, wow.
But it changed the way I looked at all of this stuff. And, that's the last project I can say that I got involved with where I didn't consider the acoustic environment. From that point on, I always thought about what kind of room is this? Is it hard? Is it soft? What are my working distances? What kind of signal to noise and direct to reverberant ratio can I expect based on the decisions that I make? And will those things be adequate in the end result? And I've never made that mistake again. That was the last time I had to take a system out.
I would love it if we could run through some of the software that you're using here, because not only is it interesting and helpful, but it's stuff that I've never seen and used before. Yeah. And you also seem to be really attracted to unbranded products. And what I say by unbranded is like, I'm so used to using the speaker manufacturer's design and prediction software and this and that. And you have a lot of stuff that is not from a speaker manufacturer and a lot of stuff that is also free.
And, I always start the software discussion in that it's a buyer's market. Back when I was getting started in this, there weren't many choices and they were all expensive. Yeah. In this day and age, there's a lot of software out there and there's a lot of good software. And I always, try to emphasize the point that, there are many choices, and just because I'm using this doesn't mean you should necessarily be using this. But it's just, I'm always trying to make the process efficient, and I'm trying to get as much information as I can with the time spent, and that governs the software that I use for a lot of things. Yeah. And I've never been impressed by market share. I mean, just because something is the most popular thing out there for doing something, that's never been a good enough reason for me to use it, because I use things that aren't the biggest player in the market. Mm-hmm. But I think it's just because people don't know about it. Yeah. Because there's not a lot of advertising, or there's not a huge user base. So I'm not afraid to use stuff that's not the most popular thing. But it's all about efficiency, and it's about getting the answer in the shortest amount of time and the most information in the shortest amount of time. Sure. And the measurement program that you pick, the measurement application is a big part of that, because if we're going to go out and tune systems and set up DSPs and stuff, you're going to make measurements. We're not going to do that by ear. There's going to be instrumentation involved. And so, the software that I use for that is software that's given me an efficient...
Just starting kind of at the beginning and going through a couple of the milestones, what are the pieces of software you run into?
So looking at the design process, what we're usually interested in knowing up front, because room acoustics and acoustic measurements is a whole thing in and of itself. I mean, that's a career for a lot of people. And if you look at all of the different measurements that could be made out in the room, you can sort of combine most of that into what we call the room impulse response. And if you have the room impulse response for some seats in the room, you basically have quantified the room's acoustical behavior. So I always try to go into the environment and get some impulse responses. And that's not a new thing. That's been true for decades. But historically, it's been time consuming, because you have to haul a computer in and microphones and run cables around and what have you. So, I've come up with some efficient ways to gather that information using recorders and sweeps into the room where, I can get in and out of a room in, 10 or 15 minutes and get a lot of data about the room. So some of the programs that I was using to do that were the program Gratisvolver that we used in the class. That is a convolver program that lets me not only produce room impulse responses, but take those impulse responses and convolve them onto speech and music and listen to the impulse response.
Right, that was really cool. We did that in the class. We took our recordings, turned that into an impulse response.
Yes.
And then we convolved a test of you speaking that was very dry, I guess. And it sounded like it was in the room.
It was exactly like it was in the room, a perfectly quiet version of the room. And that's especially meaningful to me because for the first 2 decades of my career, you couldn't listen to the impulse response. We could measure it, and we could look at it on the screen. So we used to look at these TEF screens and scratch our head and try to decide if that sounds good or not by looking at a plot, because we couldn't listen to the data. Flash forward to today, not only do we get the impulse response, but we can listen to it by itself. We can convolve it with male speech, female speech, bongo drums, whatever you want to convolve it with, and you can use this analyzer on top of your shoulders to evaluate the data. So anytime you can get listening involved in the design process, that's a plus because, again, that's what humans do that machines can't.
This is really new for me because I have done site visits where I can go and maybe we actually listen to something in the room, but not where I could actually return to that process later in the design and listen again. So I'm guessing this is coming tomorrow. I'm assuming that then we can listen to that and that'll influence our design process. So
it will.
We say, it sounds good, it sounds bad, it sounds whatever, and then we can make some decisions about, I don't know what.
Well, we're establishing a reference condition.
Okay.
So I've got this room. I'm designing a sound system for it. I need to know something about the acoustics of the space. So I put a known source into the room at a known position, usually on stage someplace, and we pick several receive positions, and we make our sweep recordings. We process those into the room impulse response. And now I've got objective data that describes how the room behaves acoustically that I'm going to design the sound system for. So now we go to our computer modeling programs where we're going to build our wireframe model of that space. And now I've got something to judge my model by, because I can do that same thing in the model. I can build the wireframe, I can put the source in there, I can put those same receive positions in there, and I can generate the response for those positions in the model, and I've got something to compare that to. And that allows me to determine if my model is reality or not. Because the thing about acoustic modeling programs is you can be way off between reality and what that program gives you can be far different than reality if you make some wrong decisions in terms of building the model and what you put on the surfaces in the model. And it's always necessary, if possible, to sort of, as a sanity check, compare it against measured data in the room. So if my room's reverberation time is 2.5 seconds measured, but yet in my model it's 1.5 seconds or 5.5 seconds, that's a big difference. And that means that my model is not going to be a very good environment for designing my sound system.
Okay.
And those two numbers need to be a lot closer before I would begin to trust that model as being representative of the actual space.
Okay. And I can see how maybe farther down the line, could we keep using that reference? So we use the reference, we compare it to the model that we set up, and then maybe even at the end, we use the reference and we see how it turned out in the room?
You can do that. You can do that because you've got something to go back and compare it to. I've always stopped short of promising that playing back the model for somebody and saying this is what your room's going to sound like.
Okay.
I think that's a little optimistic, but I think it's representative of what the room will sound like. And I can certainly use that model to demonstrate to the customer what it sounds like to be in the pattern of the main array or out of the pattern of the main array, and what it sounds like if there's too much reverberation in the room, what effect that's going to have on the speech. It's much easier to convey those things to the customer with listening in a model than it is trying to point to a plot or a chart and say that, this number's bad and that means we shouldn't do it. Gratis-Volver can give you the impulse response, but it doesn't tell you anything about it. It just lets you listen to it.
Oh, we need to be able to analyze it.
Yeah, we need to be able to analyze it. So that impulse response that I get is a WAV file, and I can open that up in any mainstream measurement program. So, I have a lot of choices there. So it can be an actual measurement program, or it can be, something not that heavy duty. So what I used in the class was a little program called Reflection Finder that is designed specifically to import an impulse response and yield the reverberation times, and some of the other measures or metrics that we haven't talked about yet in the class, things like the clarity score and the speech transmission index. Some of those things can be determined from that impulse response. Also in Reflection Finder, which is a very low-cost program that also does convolutions and some other things that, just a set of things that are useful to sound system designers, but very low overhead in terms of processing power and price, but not the only way to do it. But I just find that it's an efficient part of the workflow, and I can take that same data and open it up into a more expensive app if I want to, but I find that I very seldom ever need to, that the information I need can be gleaned right out of Reflection Finder.
Okay. So once we've looked at Gratis-Volver, CAT, and Reflection Finder, would you say is there any other important piece that you use before the system actually is finished and gets installed? Okay,
so as far as the design process goes, I personally prefer to do my room wireframes in SketchUp.
Okay.
So that's a third-party drawing program, has nothing to do with acoustics, but it can produce wireframes that I can then import into my modeling package. So for me, that's an efficient workflow because I do a lot of modeling in SketchUp for a lot of other things. So I do a lot of loudspeaker data files for manufacturers where I have to draw wireframes of the boxes and things. And I do all of that stuff in SketchUp. So I've gotten halfway decent at it.
Okay.
And so then I use that also to generate my room models, because anytime you can do anything, do stuff with one program instead of 5 programs, I can't remember how to run all of the different programs if you get too many.
It's too many.
Yeah, there's just too many. And they're all being developed at this exponential rate, and they're all growing in features all the time, and I can't keep up with that stuff. So anytime I can get rid of a program, I consider that a plus.
That's great.
Yeah, I'm not trying to use more software, I'm trying to use less software.
Once the system gets installed and you're in the field, what audio analyzer are you using there?
Okay, the measurement program that I most often use for system tuning, which I haven't used much in this class, is called FIR Capture. And it's a dual channel FFT, uses a USB, audio device as the instrumentation part of it, but allows you to collect the impulse response, process that into the transfer function, apply time windowing, multiple types of time windowing to look at the anechoic part of the impulse response, because my initial equalization decisions are going to be based on that part. And so most measurement programs do all of that stuff, but what makes it a little bit different is that it's also got a utility that allows me to do a curve fit to
a curve fit.
A curve fit. So I've got this frequency response measurement of the loudspeaker, and it's a curve. And what am I going to do with an equalizer? Well, I'm going to try to flatten that curve. So I can apply filters to that and dial them around and remeasure and try to come up with the proper filters.
I see.
It's sort of a manual process.
It's kind of like virtual EQ.
Yes, but I can also go in and say, hey, analyzer, find the best way to use 5 filters to flatten this response.
Oh, nice.
Yeah, so I get this list of these 5 parametric filters that I can just take right into my DSP, and I didn't have to, cut and try a bunch of parametric filters to flatten the curve. So it's sort of like auto EQ, but human-driven. I wouldn't just turn loose an auto EQ on a system because it can't make judgments and decisions.
Yeah.
So this allows me to eliminate the things that would fool the algorithm and get it down to just the part that I would trust it to do. And that just saves me time.
It's more like if you were to take your calculator out and calculate EQ filter bandwidth 5 times, it just saves you that time.
Yes, it saves you that time. So I can come up with a curve fast. I can get it into the DSP fast. Something that might have taken me an hour or 2 hours, I might be able to do in 10 minutes with that. And anytime you can do that and get the same answer, that's a plus.
Are there a couple of unique or interesting pieces that you would like to pick to share that you think would be interesting for people to know about?
Sure. In my little bag of goodies up there, yeah, that thing, everybody's got their own thing that they've put together that's got all their stuff in it. And, that's got some pretty standard stuff like cable testers and a voltmeter and things like that. But I've got an impedance meter. I consider that to be very important because that's what your amplifier is driving. And if the amplifier is misbehaving, first question you ask is, what is it trying to drive, and is it capable of doing that? So
you're checking the impedance of the amplifier or the speaker?
The loudspeaker.
Okay.
Yeah, because that's the load that's on the amplifier.
You can see I don't do a lot of amplifier and speaker matching.
Yeah, well, amplifiers are sort of designed to drive loads with a particular characteristic, and the load can get too low in impedance. It can get too reactive in terms of its impedance, and that will make the amplifier misbehave, and there's not necessarily anything wrong with the amplifier. I don't want to swap out amplifiers if there's nothing wrong with the amplifier.
Yeah.
And so if an amplifier is shutting down, the first thing I ask is, what is it trying to drive? So you make your impedance measurement of that. Okay. And you look at that and you say, my gosh, that's a 1.5 ohm load. No wonder the amplifier's misbehaving.
Right. And then if the amplifier's misbehaving, what do you do? Then you replace it.
Then you replace it.
Got it.
Yeah. And I might take that same amplifier and I might hook it up to a big 8 ohm resistor and see if it works properly into the resistor. And if it doesn't, it's certainly not going to drive a loudspeaker if it can't drive a resistor. So then you swap out the amplifier. You can't fix this stuff in the field anymore. It's going to get replaced and go in a box and go back to the manufacturer probably.
Okay.
Polarity tester, make sure loudspeakers are polarized properly. So I have a means, usually several different means of doing that with me, from as simple as a 9-volt battery that I might use on a subwoofer or something, to something more sophisticated like an app on my phone where I can pulse test the loudspeaker, to something even more sophisticated where I might use the impulse response measurement as a polarity test. So I've got at least 3 different ways I can check the polarity of stuff.
So if I just connect a battery, I should just see the driver go out and stop?
Yep. Okay. If you've got a direct route from the loudspeaker terminals to the voice coil of the loudspeaker.
No amplifier in between.
No amplifier in between. Just put the battery on there and it should jump out. And if you put the battery on there and it sucks back in, it's reverse wired.
Okay.
And you can't do that with tweeters because you've got a crossover network in place that won't pass the DC of the battery, but you can certainly do it with cone type devices like woofers. And I've diagnosed a number of subwoofer problems over the years just with a simple battery test. Yeah.
Nice.
And believe it or not, it's the simplest test, it's the cheapest test, and it's also the most accurate test because there's no interpretation involved.
Yep. Everyone can see.
Everyone can see.
Sure.
Yeah, and we all know anybody that's got a polarity tester on their phone or anything, you can fool those things sometimes. Sometimes it's plus, minus, minus, plus, plus, minus. You can't fool the battery. It moves in one direction or it moves in the other.
Pat, we mentioned the book Sound System Engineering. Is there another book that's been helpful to you in your career?
Glenn Ballou's Handbook for Sound Engineers.
Okay.
There's multiple editions of that. I have it all the way back to the one that I got back when I got Don Davis's book that was all tube technology at the time. And I actually ended up writing some chapters in that book in the more recent version. So that's, again, it's not a cover-to-cover read, but it's a good thing to look up stuff in. And so I've got that. I've got Bob McCarthy's book. I consider that to be excellent.
Okay.
The Yamaha Sound Reinforcement Handbook that's been around forever. That's got some good stuff in it. But in this day and age, for me, it's less textbooks and more, papers and things from manufacturers, their literature. Today we've got videos, we've got, white papers, we've got all kinds of stuff you can Google and get information on stuff. So, you glean your audio information from lots of different sources, articles in the trade magazines and things. And I've never found the single book that all of it's in.
Yeah.
And so lots of different places.
Well, where's the best place for people to follow your work?
We publish articles on a regular basis on the website. I get asked all the time if there'll be any more textbooks because, Sound System Engineering is in its 4th edition, and I'm one of the co-authors on that. And, I sort of consider our online training as my textbook.
Yeah.
And after doing that, using a multimedia approach with animations and graphics and sound files and stuff, it would be very difficult for me to go back and try to put that in a textbook. So I think, at least for me, you got to be careful saying never, but I think the textbook medium is sort of dead for me. Okay. And anything I do ongoing is going to be multimedia in the form of videos. And we'll always be publishing things like that on our website and then also in our online training.
ProSoundTraining.com?
ProSoundTraining.com.
Yes. Pat, thank you so much for joining me on Sound Design Live.
It was a pleasure. Thank you.
Sound Design Live. I want to thank Natalie for the music in today's episode. I don't have a link for them right now, but maybe by the time this is published, I will. So check out the show notes. You can do that over at sounddesignlive.com. Just search for Pat Brown. Sound Design Live is supported by Learn Stage Lighting, Scott, Pedro, Ryan, Bob, Martin, Roadie Free Radio, Joel, Ellis, Jim, Sinqui, Nicholas, Kuba, Chris, DC Sound Op, and Dave. You can start supporting Sound Design Live for as little as $1 today over at patreon.com/sounddesignlive.